Hi, for those who saw my Wandel and Goltermann level meter teardown, and if you haven't, you damn well should, because it is gorgeous inside and everybody loved this teardown. It was just a beautiful example of spared no expense engineering back in 1980. Anyway, that wasn't the only Wandel and Goltermann bit of kit I scored from that dumpster. Say hello to my little friend. Ha ha!
Say hello to my little friend!
Isn't it just as beautiful? It's the PMG-3. Isn't it cute? It's a, well, might be able to guess, it's a signal generator. It's 20 hertz to 64 or maybe 110 kilohertz here. And it's actually designed not only as a generator, but also as a receiver. Basically a standalone bit of kit that you can, take into the field. Speaking of which, it actually came in the original padded case here. Shoulder strap and everything. Look at that, it's branded, fantastic. And you carry that out into the field and you can check your telecommunications lines, your telephone lines and everything. Back in the day, I don't think there might be niche uses for this bit of kit still, really. If you do know of one, please leave it in the comments down below. But everything's newfangled digital these days, none of that voice band rubbish. Once again, it just oozes build quality. Looks like it uses the same die-cast case construction, i.e. the die-cast top, die-cast bottom, and die-cast sides with the heatsink fins, and it just looks absolutely brilliant. It's got a gorgeous looking beefy carry handle. Wow, but geez, that's not gonna, they don't make handles like that anymore. Absolutely fantastic. But check this out. It comes with the teardown tool. We've got our Allen key. This is the first bit of kit I've ever seen which comes with the tool to open it. Absolutely brilliant. Anyway, made in the USA by Wandel and Goltermann Inc. It's the PMG-3, but that was a PMG-3. I don't know what the option difference is there. 89. Whoa. All right, so I'm going to power this up. Let's see if we have better luck than the other one. Here we go. Nah. Wah. Again. Oh, well, let's crack this bad boy open with our supplied opening tool. All right, let's have a sneaky peek inside. And, there we go. Wow, pretty sparsely populated 7.4 series logic. Liking the can up there. Is that a main oscillator? Battery pack? I didn't know it was battery powered. Maybe that's the option. Almost certainly going to be no good these days. Got some analogy LF353s happening around here, but all manner of 4000 and 7.4C series logic on there. There's a crystal up there. And it looks like we have some sort of baseboard down here, some sort of side-mounted motherboard. Once again, they probably haven't wasted much space in this thing. Check out the big copper strap around the transformer there. Thing of beauty. Joy forever. And taking out this battery here, there's no screw to come loose. They've got it tapped inside this riser piece here. Disconnect the battery. That's not going to be easy to get out. Yeah, I think the best course of action, and the only course of action, is to take the bottom panel off, and then the side panel will just fall out, and the battery will just slide out. And watch this, it's all just going to fall apart, just like the Bluesmobile. No, it would have if I took off the handle first. But anyway, yeah, I thought that was going to fold out. So, anyway, we're in like Flynn. Oh, look at those big caps. Oh, there's our side motherboard. Look at that. You can get to see the copper strap. This is fantastic. Look at this. And as I said, just look at the die-cast side panels and front panel. They're just absolutely brilliant. Spared no expense. Look at the twisted pairs on the back of this switch. They didn't want to route that on the PCB because they couldn't get the twisted pair, so some grey-bearded nude virgin has wired these up and in twisted pair to just keep it balanced. Look at those tantalum caps. They're just begging to explode, aren't they? Look, they look fat as. Looks like they're ready to pop. These tag tantalums, notorious for failing. Oh, 10 mics, thank you very much. That thing's enormous. Look at that. Let's just adjust our iris, shall we? Bring all that into focus, all that goodness. As I predicted, very little wasted space inside here. Great volumetric efficiency. And everything's just jam-packed height-wise between these boards. It's absolutely fantastic. In there, take those out, and these boards will just slide out for us to have a look at each individual board. Fantastic. Anyway, my batteries pack's going to come out. Yeah, 1988. I'd say she's Gonski. Sure you won't find any of that lithium-ion rubbish in here. Well, it's not going to give up secrets easily, is it? Wrap for our protection. Multiple wires for redundancy, or for a sense line, charge sense line at the battery terminals. That'd make more sense. Got our negative going off here. You can see that they're dual cells in series, and it's tapped off here. So I think we have ourselves a bona fide bipolar battery pack here. Sweet. And they've hot snotted those together. And is that getting a little hairy scary on the top? I think it might be. I thought they might have been touching, but nope, those bad boys were welded together. Well, I'm a little bit surprised to find no-namers in there. But of course they won't be no-namers. They won't be a one hello. They'll be like, you know, a Panasonic. Yeah, that is a bit hairy scary. NiCad. Now this lithium-ion rubbish. Who was a big player back in what was it? You know, the mid-80s. And of course, with 2, 4, 6, 8, 10 cells per split supply, then we're talking about 1.2 volts nominal NiCad voltage, and yeah, 12 volt plus minus 12 volt rail going on here. They're really going to make sure these boards aren't going to come out. Not only do they have these bars screwed in here, but check this out. They've got this rod going right through a whole matching hole in all the PCBs. Those boards ain't going anywhere. So just loosen a tightening screw on there and pull that out. Bob's your uncle. We're now got access to all our boards, except for the fact that you've got to take the buttons off. Hey, that's the first one that came out. There we go. Dip socketed ribbon cable, which connects over to the front panel. That's our display board. Genuine 3M, of course, except no substitute. Oh, there you go. Didn't damage the pins. Oh, one's tiny little bend on one of them. That'll let us get the second board out. The others have all got these switches on them, and they're a dog to get out. Anyway, there's nothing on there that tells us what that is. It's 85, 40th week, 85. That could be like a jumper link, like an option setting link or something like that. Classic all digital board with your classic layout. Not many bypass caps on there. Don't need it. I've done my months in video, and classic auto-routed layout. Come on, and do that, please. Take some pride in your work. It's a nice physical layout. All the chips are in the right orientation. When you're laying out boards like this, of course, old school dipster, even today, really, with your surface mount rubbish, ideally, you want to be shooting for all your chips in the same direction. Why? Because you can, and it's nice. Gild the lily. Go on. Now, the most interesting thing about this is that, where's Wally? Where's the processor? Well, we don't need no stinking processor. It's all 74 series or 4000 series CMOS logic driving the LCD display. So they've probably got some LCD drivers, but yeah, basically there is no processor. It's just a level meter. So all they're doing is got to convert the analog signal, of course, into digital, and then just simply drive the LCD. All right, can anyone spot the LCD driver? Do you know your 4000 series CMOS numbers? I'm going to leave that up to the viewers at home. Those playing along at home, come on, leave it in the comments. So without even looking up the data sheets or numbers, you know you're going to have because of the package size, you're only going to have a like 4-bit counter, 4-bit latches, and LCD driver combined in the one chip. Basically, counter, latch, driver. Where is it? Where's Wally? So obviously that is just a display board, and yes, we actually have the full service manual for this thing, and we can, maybe we'll take a quick squiz through that as well, but that's all that does, is basically does some arithmetics and does some latching and displaying and counting and that sort of jazz. Is the synthesizer board. I've taken the can off there, it just popped off, and what do we have? We have an MC1648. That's a VCO, a voltage-controlled oscillator. Then we've got a 4011. Everyone knows what a 4011 is. Just a quad NAND gate. Thank you for playing. A bunch of, LF op amps and stuff like that. But yeah, I can put up the schematic. I'm not going to go through a complete design, a block-by-block design exercise for this thing. But this is basically our, 20 hertz or something to 64 kilohertz synthesizer. But of course, it's kind of jazzy in that it's completely digitally programmable in 1 hertz steps, of course. Of course, you do all of this with pretty much a single chip these days, at least the synthesis part of it anyway, with a direct digital synthesis chip. Those amazing chippies you take for granted these days, of course, weren't around back then. So you rolled your own using all off-the-shelf parts. I can't get this board out because there's got this back plate, so it looks like I may have to undo the power supply section from the back, and then of course it'll just lift out. By the way, just take a look at the cable harnessing going through the grommet there. It's all very nice. Unfortunately, to get at that, you've got to take this back panel off, but thankfully, they haven't stuck that on. It's screwed in. There's the screws under there to get the card frame apart. So, yeah, it's just nice that they did that instead of just stuck it on. And there we go. That just slides out. A little bit of extra room there. Lift this board out. Winner, winner, chicken dinner. And this is the level board, hence all the controls. If you want to have a look at the front panel again, correlate it to there. And I give you a decent look around that. There you go. Once again, full schematic and service manual is available, so we could actually go through this block by block, but do you want this to be an hour long? One thing you'll rarely find in these Wandel and Goltermann products are bodges. There just really aren't any. Check out these. We've got some components on standoffs there. Select on test kind of thing, and then solder them in later, because at the production stage you solder in the little pin offset things, and then you can select the resistors and put them in later. They got one over for the cap over there. And this one is shielded on the bottom. A little bit of flux residue left over there. Somebody didn't clean up. That's common for the day. So when you're designing this thing, you can't just lay out your front panel willy-nilly, because you have to group the things together on the functional boards, because you've got the physical switches into your PCB. There's no front panel board and then some wiring harness going over or something like that. You can probably guess what the next filter board does. Oh, just spoiler alert right there. It's a filter. And there's our filter board, a big frequency devices filter there, 827 hertz. Of course, that would be to correlate to some, CCI-TT or something industry standard. I'm sure someone will correct me on that. Look at our big ass caps on here. Of course, these are 1%. Thank you very much. These, of course, would be a high stability poly put the kettle on type, and that's why they have to be so physically large, because in a level board like this, a level control circuitry, of course, stability is the key factor. You don't want your capacitance to drift over voltage or temperature or anything else. And on the back here, we have Smith's potato crinkle cut. Thank you very much. I've explained this sort of stuff before, why you get all this crinkly. It's not actually the solder mask that's crinkling back then. This was common for the day. The entire board, the process is different back in the day. Today we have what's called SMOBC, or solder mask over bare copper. So when they etch the PCB, you just have the bare copper traces left, of course, and all these big ground fills will just be bare copper, and then they will put the solder mask directly over the bare copper, hence the name. In the old days, they would do a tin plate. They would roll tin plate it usually, and then solder mask on top of that. If you zoom in enough, you can sort of start to see it on the traces as well. It's just not an even process. It's not hot air leveled or anything like that. It just is what it is, and then they solder mask over the top of that. So you're left with all these little waverly, crinkly things, especially on big, fat ground planes. And you can see the residual tin plate down there where they've masked off that solder mask. And we've seen the driver or I/O board, as they call it, before. Once again, like we have some balance here, some balance transformers. Once again, the big 10 microfarad poly put the kettle on, high stability coupling caps there. Of course, they're not doing any bypassing. They're coupling the things because you want high stability in your coupling caps to get good linearity and all that sort of business. There's not much else doing there. LM317, thank you very much. And dumbass Dave does it again. I think I've come a guts, and there's probably been a whole bunch of you screaming at me since the start of this video. Dave, this isn't the on-off switch. Look, it says dial there. The power LED here, I just realized that there's another on-off. Because at first I thought, oh, it was a clicky, end stop thing. You turn it off and then on and then increase the volume. But no, you pull it. And I'd even printed out the schematics and everything, just getting ready to troubleshoot this thing. It's just a linear supply. There was that dial part with the LM317 and stuff. It was, yeah. Anyway, I don't think we're going to need that. I'm going to pull that, and I'm assuming that's going to come on. Whoa, listen to that. Do that again. It's beautiful. You can hear the oscillator starting up. One thing that's interesting to note, when I change the level display, you'll notice the frequency change. It's bouncing around there. It's got to stabilize. Can I smell something? Check this out. This is the most amazing thing. This dial. Look at this. Look. I can spin it. Oh, it's pornographic. Going up. I love the noises. And yep, it does actually work a treat. Check it out. You see it, it bounces around. It takes a little bit to stabilize there. Whoa, that's not looking too good, is it? That's at, what, 40 hertz? Oh, okay, yeah, I think, yeah, it only goes down to, oh no, it's supposed to go down to 20 hertz. That's 37 hertz. So, sorry, you can't, it's not easy to read the LCD, but that's 37 hertz. Wow, that's a bit how you doing. And then all of a sudden it just comes good, almost comes perfect at about 43, something like that. So, what, 20 hertz? Give me a break. And does that at lower amplitudes too, so not sure if that's normal. Yeah. Love it. And the level's okay, but it does actually, according to the display here, it does actually jump around a bit. I thought I'd just single shot capture that, but it's fine. Geez, that's annoying. So there you go. I hope you liked and look at yet another Wandel and Goltermann bit of kit. The little brother this time to the other one, which was, well, this is like an all-in-one unit. The other one wasn't quite all-in-one. It was designed to be part of a system. There were other units which are tied together, and you can, someone pointed out that you can hook them up to plotters and things like that and actually get frequency response plots and all sorts of brilliant stuff like that. But anyway, this one was cute. I love it, but yeah, pretty much obsolete these days. What would you get for it? $10 on eBay maybe? I don't know. But anyway, if you like the video, please give it a big thumbs up. Look at the size of that thumb. Wow, all in 4K. And as always, comment down below in the comments or over on the EEVblog forum. And yes, I will eventually get back to the other Wandel and Goltermann one, because as somebody pointed out, I missed an entire section of that. And also I probably want to have an attempt at a repair for that thing too. So yep, stick around for that. Catch you next time.